Hello everyone, welcome to Code Design. In this video, let's discuss this problem, count distinct subarrays. And before starting the video, I would like you to hit that like and subscribe button. So let's start. Let's first read the problem statement. You are given a permutation of n length n, and a permutation is basically an array containing numbers 1 to n, and every number is unique. Okay, so all the numbers from 1 to n are present, and it can be in any order. So we have to for any prefix till I, we can select three distinct indices I, j and k, such that ak is less than aj and ak is just an and for any we can perform operation possibly 0 number of times, such that we can select three indexes jk and l, such that ak is less than aj and al. Equal to will never occur because it is a permutation and of length n. So and then we have to delete ak, and we need to print what are the number of distinct arrays that we can find, right? And n goes to 5 into 10 is per 5, so we have to look for an big of n type solution. And let's try to understand the sample input first. So we have four integers, 4 1 3 2. Okay, so like for the first subarray, for the first prefix, the answer is obviously 1 because I can't delete any element here. Also for the these two elements, because we can't even select three indices, right? So the answer will be 1. But for 4 1 3, I can either decide to take or not take this one, right? So I can either get 4 1 and 3, or I can get 4 and 3, right? So this for this case my answer will be 2. And for 4 1 3 2, I can see that this 2 will not contribute to the answer because it is much less, so the answer should be 1 1, because there is no and for this 2 I can say that this 2 will not contribute to the answer because on right I can't remove this 2, right? So the last element cannot be removed. So and also it is less than the previous element, so it will not contribute to the answer. And the answer for this one is 1 1 2 2. So these are the distinct prefix that we can get, and that is correct. And this case is also easy because it is fully sorted. Then for every index I, the left one is less than current index, so we will not be able to delete any of the elements. Let's see a different permutation and try to understand that, like 4 1 2 3. If this was the case, then we could the answer will be 1, then 1, then I can delete one more, and I can delete 4. So I think it is pretty straightforward. Like, how did we get 4 here? One possible is 4 1 2 3. Then I could decide if I want to have this one or not. If I want to have this, it will overlap with this subproblem. So I can try to delete 1, so 4 2 3. Then I can try to delete 2, then I will get 4 1 3. Now from this one I decide to take 2 or not, so I will get 4 and 3. And now, and from this subproblem, if I delete 1, it will be the same as this one, so that is basically the same thing. So we will get 4 distinct subarrays. And since we have overlapping subproblems, so obviously some kind of DP will be used here. So we can solve this using dynamic programming, and let's see how we can do that. So now we are discussing the approach. uh, so I can say let dp of I is equals to answer for prefix I. Right. So let's assume that I know dp of I, and from this dp of I will try to find the answer for dp of I plus 1. So basically I'm trying to solve the prefixes. So now if I solve all the prefixes, I will finally reach the answer, right? uh, let's say also that m is equals to maximum of p1 p2 till pi. So let m is equals to index. So if my m is the index of maximum of these elements, like maximum of this prefix, so if I know m, then my array will look something like there are some elements in here, then there is m, then let's say we have the second maximum, then we have the third maximum, and then we reach the array of I, right? So, and because I already know the dp of I minus 1, so since I already know dp of I minus 1, these are already computed. So I have the value of dp of m, I have the value of dp of m2, I also know the value of dp of m3, and now I want to find the value of dp of I, right? And since I'm only that this is a of I is the, let it be the fourth maximum for this one, or we can say the kth maximum. So what will be the answer of dp of I? Now if I consider till m2, then I can say that this is a separate subproblem. M can never be removed, right? Because it is the maximum element, it can obviously never be removed from this prefix. And m2 and but when I reach m2, all the elements between m and m2 can be removed. So I can say that dp of m2 is simply dp of m times 2 to the power 2 to the power m2 minus m minus 1, right? How? Because like for every index I have two possibilities, either take or not take. For this one also I have two possibilities, take or not take. So like when I reach here, this was the maximum, and the gap, and this 3 is the third maximum, right? Sorry, for second the maximum. So the answer is dp of 0 times 2 to the power 2, and that is the answer, right? So I can say that the second maximum, this will be the answer. And let's say what will be the answer for the third maximum. So dp of m3 is equals to, I can say it is the now all the elements between the second maximum and third maximum can be deleted, right? So it will be equal to dp of m3 into 2 to the power m2 minus m3 minus 1, right? And sorry, this should be m2. Now why m2 can't be deleted? Now m2 can't be deleted because m2, because if all these elements are deleted and all these elements are deleted, it is strictly decreasing order. So m2 can never be deleted, also m3 can never be deleted. And then we reach ai. So ai is equals to, I think we can still simplify this further, if we have dp of m2, then if I substitute this here, then this will become dp of m times 2 to the power m2 minus m minus 1 times 2 to the power m3 minus m2 minus 1. I made a typo here. So this is overall dp of m times 2 to the power m3 wait a second, this is these two will cancel out, and this minus 1 will remain, right? So m3 minus m minus 2, right? And then similarly we can say dp of I is equals to dp of m times 2 to the power mk. If this is like we need to know what is the that array of I is the kth maximum, so dp of I is equals to mk minus m minus k, something like that, right? We can conclude it like that. But now how do we find this in O of n? Because the time complexity can only be done in O of n or O of n log n. We can't spend more than this, otherwise it will give us a TLE, right? So so we can use previous greater element, something like that, to find the what was the previous greater element till m3. Then we go to m3 and then find the previous greater element to m3, that was m2, and like that. But this is an O of n square approach, but we can be smart and try to do this same thing in big O of n. So we can try to be smart and reduce this to big O of n by maintaining a current answer and updating it. So let's try to dry run this let's try to dry run this approach. So let's say we have 10 numbers and we have this array like 6, 5, 9, 10, 3, 7, 4, 2, 1, 8, right? And we want to we are using a concept called previous greater element. So previous greater element. So if you don't know about this, kindly first go and watch a video on YouTube. There are plenty of videos on it, and come back here. So like for the previous greater element, we use something called a monotonic stack, right? So I will just draw a stack here. Yeah, and like this is the 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's say my current answer is equals to 1. Okay, and I will push 0 in the stack, so my answer is 1. And now I reach at index 5. So before doing anything, I will pop out all those indexes from the stack which are less than 5. So but 6 is greater than 5, so I will keep it. And now I will have to check what is the what is the top element in the stack. Like if my stack is not empty, then I can do like, okay, what is current is equals to current times the answer of stack dot top I can do current is equals to current times 2 to the power I minus whatever the top element of the stack is there. Like I have 6, the answer at 6 is 1, and now I am at 5. Then I can do is, okay, multiply the current answer by the gap between these two, the stack dot top and this current element, which is 0. So my answer here will not change simply, so the answer will not change. But let's say I reach 9, and when I reach 9, okay, I push 1 to the stack before, and when I reach 9, these two will be popped out. Okay, and my current answer is still 1. Like when I reach 9, my current answer is still 1, and Now since now I will check if my stack is empty, and since my stack is empty, I know that 9 is my current maximum. So I will also have to maintain a my m index, that the what is the maximum till one index before, right? So this will tell me that okay, my maximum was 6, the 0th index. So I will say okay, the answer right now, let's update the current to dp of m times 2 to the power what is the distance between these two, I minus m minus 1. So there was a distance of 1, right? So I can say okay, it will be equal to 1 into 2 to the power 1, which is equals to 2. I hope you were able to get that. I'm using some permutation and combination. Next I reach at 3, and okay, there was a 2 here, and when I reach at 3, this is again empty, and my variable m will tell me that the prefix of this array till prefix of the array till index 2 was 9. So there was no gap between them, so my answer will not change, and I will push 3 in the stack. Okay, then I reach at 4. It is strictly decreasing, and like my array is something like, okay, I have reached 10 at index 3, and then we have a 4, right? So this is my m and this is my m2. So what was dp of m2? Dp of m2 is equals to dp of m2 is equals to dp of m times the gap between them, right? So and dp of m is equals to 2, right? Dp of m is equals to 2, so I can and I only have access to m, right? So I can say that okay, no problem, my next answer will be 2 only, because there is no gap between them. I will multiply it with 2 to the power 0, and my answer does not change. Okay, so my current answer is 2. Next I move to 7, and when I move to 7, my current answer is equals to 2, and okay, I have pushed 4 here. Now now when I am popping this, like when I reach this 5, this 4 will get popped out, and then I see that okay, this one is 3. So now I need to, like, dp of m, I have this dp of m, the stack dot top will tell me mk minus 1, right? This stack dot top will tell me the dp of mk minus 1. Like we needed this like a of I, this stack dot top is telling me the value of the previous greater element, but we don't need this, we need this dp of m, right? And to do that, I will have to divide this whenever I am popping it, I have to divide the current by 2 to the power the gap between these two. I think it will get more clear in this 7 and 8 test cases. So let's quickly try to jump there. So the answer for 7 remains 4, right? Because there was a gap between 10 and 4, and so I will say okay, dp of 3 times dp 2 to the power 1, because there was a gap, so this becomes 4, and my current answer is, and my stack looks like this. I have a 3, then I have a 5, and my current is equals to 4. Okay, then I reach out this 6th index, and I realize it is smaller, so I will just push it 6, and my answer does not change. Then I have a 2, so I will push this, and my answer does not change. Then I have a 1, so I will push an 8 here, and my answer still does not change. Okay, but now I reach at 8, and now I have to pop all these elements, right? Even my 7. So popping these will not change anything, but when, like, if I don't know this index right away because it is in a stack, and when I am popping it, it is also if I, and when I am popping it, I can update this current variable only to reach this 2, right? So I will just I will just pop all these and say okay, dp of, since I'm storing this, like when I will pop this 5, I want my current index to point here, because I want to say okay, current is equals to current times 2 to the power this gap, right? So whenever I pop it, I will check the second top element in the stack, and then divide it by the, not multiply, I will divide it by the 2 to the power the stack dot top, let it be x minus y minus 1. I think it will get more clear in the code, so let's just move on and try to code this approach. So I will make two array, so int power of 2 till n, and inverse power of 2 till n, and let's reprocess them. So for I in range, it will go from 1 to capital N, and I need the modular inverse function to calculate the inverse modulus for me, or I can simply use power mod minus 2 and take mod with that, but this will also work. So power 2 of 0 is obviously 1, and power 2 of inverse 2 of 0 is mod inverse 1, right? Now I can do is okay, power 2 of I is equals to power 2 of I minus 1 times 2, and take the mod, and power, why is this giving an error, mod inverse, okay, and let's also say that to the inverse. Okay, using this we can pre-calculate the power of 2 and inverse power of 2. After that, let's see the input format. Input format is, first we have an integer n, then the array. So let's first take the integer input, int n, cnn, then vector int a of n and for I, cn a of I. Okay, so now we have the array, and so first let's write the code for previous greater element. So I'm going to use a vector for a stack because I also need to access the second topmost element sometimes. So for calculating the previous greater element, let's run a for loop while stack dot size int u is equals to stack dot back. If a of u is less than a of I mean greater than a of I, then we don't need to do anything. So break it, otherwise I will do stack dot pop back, and then stack dot push. Push back I. Okay. And here we do something like previous greater element of I is equals to stack dot top, something like that, but we don't need to do that here. I can when we have this code for the previous greater element, right? Now we need to somehow calculate our answer with this. So I can say, okay, vector int answer of n, and let's say my current answer was 1, and in here I will simply say, okay, current answer of I is equals to, answer of I is equals to the current variable, yeah. And now that we know the before popping out this element, I have to reverse the effect on my current variable. So I will say, okay, if my stack dot size is greater than 1, then I have to check the index of the previous element. So let's say int v is equals to -2, and current is equals to current times inverse mod 2 u minus v minus 1, and take mod with it. So now this reverses the effect of the elements in between. And now here I have to just check if my stack is my stack empty. If my stack is empty, that means that my current element is maximum in the whole maximum of the whole prefix array, right? So I think I can make one more variable, int prefix max is equals to 0. Okay, so now I can say if a of prefix max is less than a of 0, I mean a of I, then prefix max is equals to I. Okay, so this will give me the maximum prefix that is till the current index. Now I have to check if my stack is empty. If my stack is empty, if my stack dot size equals to 0, then what did I do? Like when I reached 10, my stack was empty because that was the current maximum. Then I have to check what was the answer for the prefix maximum till the prefix element. Like what was the prefix maximum till 9? So I should not do this step here. In fact, I should do it like in the end of this, right? So what was the if my stack is empty, I have to get the answer for this element, like what the prefix maximum before 10, before this is occurring. So this is if my current index is the maximum of the whole prefix, I will just do this, like current is equals to answer of prefix maximum times 2 to the power, so power 2 of I minus prefix max minus 1, and take mod with it, right? And in the else case, I can say, okay, this is, if this is not the case, then I have a top element, which is if this is not the case, then I have some element and on the stack. So I can say, okay, current is equals to current times the 2 to the power 2, and what is the element on the top? I minus stack dot back, so minus 1, and take mod with it, right? And after this I can simply say, okay, cout current, and then cout endl, and I think this should work. Oh, it failed all the test cases. I don't know. Let's try to debug this. Debug. Let's try to debug the code. Like, okay. So debug the. Let's debug the stack and debug the answer, and also debug the prefix max, and let's do it for this test case. So my stack is working, but my answer is not updating because I said answer of I is equals to current. Let's debug the current also. So why is my current 0? My current is 0, and that is because answer of prefix max if my I think this is because I think I should skip this step for I is equals to 0, because my answer of prefix max is not set for I equals to 0. So if I do this, now we are getting the correct answer. Let's remove this from here, and okay, so this is the code, and I hope you were able to understand that. Let's just copy it and see if it works. So we got the correct answer. I hope you were able to understand that. Kindly like this video, and I will see you guys next time. Thank you.